Today we're going to study the standard normal curve, which is representative of normal distributions. The shape of the curve is bell-shaped and is symmetrical around a mean. The horizontal axis corresponds to z-scores, which are quantities of standard deviations to the left and right of the mean. Characteristics of the standard normal curve are that the cumulative area increases as z is increasing. So as z goes from left to right, the area is increasing. The cumulative area is exactly half, 0.5, at a mean of 0. The total area under the curve is always equal to 1. In our problem, we're asked to find the area underneath the curve between a z of negative 2.18 and a z of 0. Now, the area at z equals 0 would be actually half of the graph, which is 0.5. The area from the left all the way up to negative 2.18 can be found either from technology or from tables in the back of the book. So I have the standard normal table from the back of the book. I'm going to look up negative 2.18. The left-hand column represents the first two digits, negative 2.1. And the column heading, it represents the third digit, which is 0.8. So negative 2.108 is a value 0.0146. So if we take that value away from 0.5, we get the area between the two z values of 0.4854. For our next problem, we're asked to find the area between the z values of negative 2.45 and positive 2.45. Well, the area at plus 2.45 all the way from left to here, if we take away the area up to minus 2.45, we would have the answer. The area corresponding to a z-score of 2.45 can be found from our chart. So I'm going down the left-hand column and looking for 2.4. And I'm going over to the column heading 05, and I'm reading 0.9929. I want to take away from that the area up to the z value of negative 2.45. So negative 2.4 in the left-hand column and 505 in the column heading, so is 0.0071. If I subtract the two values, I come up with 9.9858. Observation. The area to the right of 2.45, this area in the tail, is equivalent to the area in the tail on the left of minus 2.55. They're both the same areas. For our last problem, we're asked to find the probability that z is greater than minus 0.87. So here's the standard normal curve. I graph z equals negative 0.87. We want the area to the right. Remember, the standard normal curve values calculates the area from the left up to, not the area to the right. Well, the way we can calculate this is if we want to find the probability that z is greater than negative 0.87, what we want to do is subtract the z value from the left up to this point away from 1 to come up with the area to the right. So 1 minus the probability that the z is less than negative 0.87. So less than negative 0.87 is this left-hand tail. Negative 0.87 is 0.1922. So if we take this area away from the total area, 1, we come up with the area to the right, which is 0.8078.